Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Max Beauchemin about Superset, an open source platform for data exploration, dashboards, and business intelligence. So Max, can you start by introducing yourself?
For sure. Well, first, thank you for having me on the show again. So that's 2 back-to-back in a short period of time. But yeah, quick intros for people who missed the previous episode. My name is Max. I'm the original creator of Apache Airflow and Apache Superset projects that I started in 2014-15 while at Airbnb. Since then, I've worked at, Airbnb, Lyft, at Facebook before, doing data engineering. So I've been really involved in the world of data engineering over time. And since before data engineering was data engineering, since then, I started a company called Preset that basically serves Superset as a service and, with all sorts of bells and whistle, and that's like completely hassle-free. So we're very strong contributors in the Apache Superset community. And then we're strong operators too, because we operate the software at scale on the cloud as a cloud service.
Yeah, and as you mentioned, you've been on the show before, both this one and my other one about Python. So you are actually on, I think, episode 3 of this show back in 2017. So one of the first guests to get this show off the ground, talking about what even is data engineering. And then before that even, you were on podcast.net to talk about Airflow. And then recently you were on there to talk about Superset. So for anybody who wants to get more about the backstory of the project and how it works under the hood, I'll put the link in the show notes for that. And so
I was going to say too, it's been a little while. It'd be really interesting to revisit some of these questions too. Like, what is data engineering? How has it changed over the past 5 years? There would be a lot to talk about. Save that for yet another episode.
Absolutely, yeah. We'll have to have you back on to say, what is data engineering now in 2021?
Exactly. Even before the show, we were just chatting here and we're talking about how we're doing data engineering as a startup now. So Preset, the company I started, is about 45, 50 people now, and we don't really have a data engineering team. And it would be cool to talk about how really small data-driven company, how they do data engineering and what's the emerging stack there too. So I'm signing myself up for many more shows here.
All right. We'll have you on every week for the rest of the year. And so for people who haven't listened to any of the other episodes that you've been on, can you give a bit of a refresher about how it is that you got involved in the area of data management?
So I started my career very early on. I did 1 year of web development super early on with tools that people would not even recognize the name of anymore. So I think I was doing ASP, Active Server Page, before. .NET was even a thing. And there's a time where we'd write VB script on the client side, not even JavaScript. That was possible to do that back then. So did a tiny bit of web development and then jumped into an early data career when, at that time, I think data warehousing existed. There was resources like the Data Warehouse Institute was a big thing. Ralph Kimball and Inman were kind of the grandfather now of data warehousing. So there was some literature, some best practices, but it was a very different world back then. The term data engineering did not really exist. Tools were mostly drag and drop. And that's when I got involved into it working for a company called Ubisoft, a video game company, doing all sorts of data management for them, more in a financial. So we were doing a lot of supply chain, retail, and then a lot of financial type data too. So general ledger, accounts payable, so accounts receivable. So very different than your kind of growth analytics. A little bit later on, I joined Yahoo, where it was really the rise of big data and kind of the birth of Hadoop at the time. That was heavily kind of financed or sponsored, is probably the right term, by Yahoo at the time, and went on to Facebook. And the rest of the history then went on to Airbnb, where I started working on open source.
For the people who haven't listened to the interview that we did on the Python podcast about Superset, can you give a bit more of an overview about what Superset is and the main use cases that it's being used for, particularly as a data engineer?
For sure. Yeah. So Superset is an open source data exploration visualization platform. We're very much in the business intelligence and data visualization space. So if you're familiar with tools like Tableau and Looker and Data Studio, right? Like we're very much in that space, but as a strong open source kind of counterpart in that area. So if, data sovereignty is important to you, if having a more modern type set of tools or a platform that's a little bit more modern and more probably extensible and flexible, I think Superset is a great choice now for all the reasons related to the fact that open source is great, right? It's just a better way to write software. It's a better way to distribute software. That makes for software that is more malleable, that people can turn into exactly what they need it to be. So really happy, and it's kind of life goal for me to get a very strong open source solution in the space that's a strong contender that can really compete with the more proprietary tools in the space.
Digging a bit more into sort of the broader ecosystem around Superset, as you mentioned, there are a number of tools, both proprietary and open source, and I've been seeing increased references to Superset as being kind of the default for people who are building out a new stack, particularly around the open source data ecosystem, where it might be S3 with Trino and Superset, or S3 with BigQuery and Superset. And I'm wondering what you see as being the motivating factors for Superset gaining so much popularity in this space when there are other players such as Redash or Metabase on the open source side, and Looker and Tableau and Data Studio, and I don't even know how many other options in the proprietary side.
The very competitive space, that has a lot of history. So I think like people have had business intelligence budget for the past like 2 decades. So it's a well-known space that's fairly mature at this time. So the first case is right to talk about. I think there's kind of 2 paths to explore the kind of advantages of something like Superset in the space. One is open source and everything that comes from open source. So it's really clear to me that over time we've made a case for, and we've had like kind of global acceptance around like why open source matters. As a matter of fact, a blog post on the topic that we published a few weeks back that's called The Future of Business Intelligence is Open Source, where I explore, why is open source winning in general, and how does that translate into the space that we're in, right? So I tell a bit of the story of Superset and how it came to be, and then talk about things like extendability and integratability, like just being able to integrate Superset with whatever you use because it's open source, right? And being able to customize it to fit your need. On that topic, there was a really good blog post out of Airbnb that's called something like how Airbnb's turbocharged Superset to power their more specific use cases, right? And it's the story of how they customize Superset to make it really work for them internally. Outside of that, because we're open source, we have the power of the community. I think other tools like Tableau and Looker have some sort of like user community too, where, people meet and exchange. But I think with open source, that's such a strength, right? And such a natural thing to have the community. And that enables us to have like really good documentation, really good example use cases, just like a very dynamic community that's really supporting the project and the rest of the people in the community that are using Superset. One big thing with open source that's clearly a theme is like avoiding lock-in, right? And I call this data sovereignty. So it's the idea of like really owning, be able to customize, change, get the help that you need, select a vendor if you want one, and having the ability to take over as needed, right? So if something happens with a vendor that you might have in the space, or you're never locked in, you can always go and decide to take over the software and run it on your own. So I think that's a really important guarantee. Companies like Tableau and Looker got acquired. There's more example in this space. There's been a fair consolidation in the space. Chartio recently got acqui-hired, so that leaves people that use Chartio today like having to off-ramp in the next year. So for these people, I think to tell them like, hey, you've been burned once, like maybe this time around you might want to select something that's open source. So that's covering the open source aspect. The other aspect is around probably like the convenience of cloud native and SaaS. And, I would say on that front, there's a lot of vendor tools in the space that have more kind of previous architecture, that are more kind of desktop based, or that don't work as well with the modern data stack. And I think that's a strong differentiator for Superset. And then there's this idea of like, the convenience of a cloud-based tool. And I think like we've seen that in other spaces that are not business intelligence, data visualization. And you think about things like on the data warehousing side, people love the convenience of BigQuery and Snowflake because they're just kind of serverless, and it's really software as a service where you don't need to have a DBA, or if that term even still exists, right? Or you don't need like anyone to be on call for the database because it's a service. So I think like open source now, we see the rise of a commercial open source vendor that can be really good partners in getting the best of both worlds, and in terms of like getting the guarantees that come from open source I was talking about, plus the convenience of having a service without the lock-in.
Modern data teams are dealing with a lot of complexity in their data pipelines and analytical code. Monitoring data quality, tracing incidents, and testing changes can be daunting and often takes hours or days. Datafold helps data teams gain visibility and confidence in the quality of their analytical data through data profiling, column-level lineage, and intelligent anomaly detection. Datafold also helps automate regression testing of ETL code with its data diff feature that instantly shows how a change in ETL or BI code affects the produced data, both on a statistical level and down to individual rows and values. Datafold integrates with all major data warehouses, as well as frameworks such as Airflow and dbt, and seamlessly plugs into CI workflows. Go to dataengineeringpodcast.com/Datafold today to start a 30-day trial of Datafold. Once you sign up and create an alert in Datafold for your company data, they'll send you a cool water flask. Another interesting evolution of the overall space of data engineering and data management is sort of where the responsibility lies for tools like Superset, because on the one hand, it is kind of the responsibility of data engineers to be able to provide data in a manner that's clean and accessible for other people to be able to do analytics. And on the other hand, there are roles such as analytics engineers and data scientists are becoming more savvy for some of these infrastructure aspects where they might be doing all the analysis in Jupyter, or the analytics engineers might be handling kind of the transformations using dbt or something. And where have you typically seen the responsibility for getting something like Superset deployed and managed? And then where's the dividing line between the kind of data platform and data engineer providing the tools, and then do you see them moving into actually building the dashboards as well, or does that fall somewhere else within the kind of role of responsibilities in the data team?
That's a good and complex question too. I think it relates to what I would call like the data maturity life cycle of a company too. So I think depending where you're at on your data team or like data literacy journey and culture as a company, this question would be answered probably in different ways. In terms like from an infra standpoint, who is in charge of operating the tool, or even like selecting and then providing service and being on call for the tool? I remember in the rise of the data engineer, which is a blog post I wrote a long time ago that probably was before our first interview. That might have triggered our first interview. I don't know. I forgot. But I talk about how in smaller organization, data engineering is also, supports the function of data infrastructure management. So if you have like 2 data engineers in your organization, they probably are in charge of either selecting the vendors or selecting the software that's being used and making sure that software runs and that they probably are on call too for when it gets down. In bigger organizations, when I was at Airbnb, for instance, right, there'd be a clear distinction between a data infra team and the data engineering team or function, right? And then clearly the data infra team is like very horizontal, and in terms of like it supports the organization as a whole. Where data engineering, there's a little bit more attention to kind of pull them vertically, right, to be a little bit closer to maybe certain product verticals in some cases. Then in terms of like who builds the reports and dashboards. I threw the term data literacy a tiny bit before. So talking about this, I think more and more people going from the information workers, right? So people were just like people who work with a computer every day and, answer emails, and whether they're, PMs or business users of different kind of anyone, the organization really need to become more sophisticated with data. And we see these people using Superset and self-serve there, like whether it's consuming a dashboard or using the no-code explorer inside of Superset, right? They might not know SQL, but in Superset, they're still able to do a lot of like slice and dicing using the drag and drop type interface. So generally, I would say that more and more people, like regardless of their function in modern organization, have to become more data literate and familiar with powerful tools like Superset. The vision for Superset is really to be across the whole consumption layer and to cater to the different level of sophistication of users that might be more or less like data literate, right? So you can imagine that within an organization on the data consumption layer, you're going to have people who just kind of consume dashboard that have been built by others, people in their team or their like analyst partner or data engineer, like whoever has built a dashboard that's relevant for them. Then, I think we see a lot of people being able to do a lot of slice and dicing. And there's a SQL IDE in Superset. So if you do speak SQL, and we see more and more people across different functions learning SQL nowadays. Good example of this is Airbnb has a program internally called Data University, where everyone in the company is invited to learn more about their data warehouse, data structure, learning SQL to empower them to do better at their work, right? The last one I would mention that's complementary on the consumption layer that goes up the ladder of sophistication is the notebook, right? We see the notebook as if you can't do it in SQL because, I don't know, maybe there's a machine learning component to it. Maybe there's some crazy wrangling that's better done, in a data frame than in SQL. We see notebooks as that last layer where it's less accessible, it's harder to use, but it's much more flexible and powerful.
Another interesting aspect of something like Superset, because it's not just a static dashboard where here are some pretty charts and maybe there's a limited amount of being able to reorient the axes or something. It also has a full-fledged data exploration layer. And I'm curious what you see as the opportunities for collaboration and sort of the capabilities that Superset has for being able to version and fork and merge different queries.
There's a fair amount to unpack here. The first one is like collaborative workflow, and on the data consumption layer, I think that's to have collaborative tools are transformative in a lot of ways, right? We've seen Google Docs versus Microsoft Word, is a game changer for a lot of us. So we're definitely bringing a lot of this into Superset over time. There's direct collaboration on the document, and there's like social aspects too that are similar and intertwined. I would say, they're in a similar space conceptually, but I think like the social aspect is something that the internal data tooling at Facebook was really great about. So in most of the data tools internally at Facebook, you would have kind of social aspect of like, who's the owner, who's using this data set, who has created this chart, who's consuming it, and then a way for people to kind of leave comment or annotations for other people. So that is an important aspect that we have already in Superset to a certain extent, and that we're pushing forward. Now there's a question of like, do we want to have two people working on the same query or the same dashboard at the same time and see their cursor move around? And I think, at least from the SQL IDE perspective, if I'm writing SQL, I'm like, don't touch my SQL, don't modify my SQL. Like, this is my thing. I can share my query with you, but I don't want to be collaborating on SQL per se, like in real time. But I do want to share queries, which we allow, and we're going to add a lot more around like the commenting type interface, social collaboration within the tool, which I think like is super important, and we're investing in that. I think like all tools nowadays really need to move in that direction. That's something that users expect.
Because of the fact that there is this data exploration capability and you're handing that over to people who are trying to answer their own questions and maybe don't have the same level of training with distributed systems and query optimization as a data engineer or a data analyst, what are some of the potential challenges that somebody who's providing Superset as a service to the organization might run into, and some of the ways that they might avoid allowing people to end up in a suboptimal user experience because of performance issues with the queries, or trying to bring in too many different data sources together in one visualization or something like that?
There's a fine balance there, between like giving people power, but also preventing them to shoot themselves in the foot. Generally, in software, I think one thing that people don't appreciate as much as they should is what it takes to harden a piece of software. It's pretty easy for anyone to write, a competitor to something like Airflow, to be like, I'm going to write a small scheduler and something that writes DAG. But I think the real part of the real value of software and of open source type workflows and type approach to development is that we can massively harden a fast moving piece of software. And you'll see over time that software, will build an immune system. If you think of software as an organism, it's like every time that there's a little cut or a little break or something that hurts, we think of a solution to prevent that in the future. And sometimes it's like from an architecture standpoint or from a pull request beauty standpoint, it's not always the most beautiful piece of code. That might be adding a retry decorator in the right or wrong place. But there's a tremendous amount of value that exists in that. Now, what does that mean for something like Superset? So one thing is like, how do we prevent ad hoc user from destroying the underlying analytics database? So luckily, I would say Superset is architectured in a way that is doing like most of the heavy lifting on the underlying database. We're like, oh, not our problem. We just push all the heavy lifting to the underlying database. You can go and, destroy that through our powerful tools. So we do offer some ways to prevent some of that. And that's part of the immune system we've built. I think that responsibility of like hardening the underlying database is probably best done. So say if you're using something like Presto, and I forgot, Trino or Presto, whatever one you picked in that space, I think Presto is probably receiving a mixed bag of queries, like one on one end from Superset. But Tableau, maybe have you look, or maybe you have collections of other tools. So I think it's important for the database engine itself, or for the database, organism to defend itself pretty well. We do have some hooks in Superset that enable people to kind of hook in and control a little bit more the flow of what's happening. I know at Lyft, I think we had some sort of like proxy in front that would do some routing and some rate limiting and some queuing, to help Presto. So as a Presto proxy. In Superset itself, we do have things like a query mutator and a connection mutator, where it's easy to add configuration inside Superset that will intercept certain pieces of SQL and the database connection on its way to the database. So you can add logic in there that could say something like, if there's a lot of query running, don't send the query over and wait a little bit. Or you could say, run an estimation ahead of time. And if the estimation is like less than a certain amount, or is bigger than a certain amount, kill the query. So we have these configuration hooks that can be used to intercept, query, and route things. And that's probably the extent of it. I think we have a feature behind a feature flag that is a button in SQL Lab that enables people to estimate the cost of a query prior to running it. So that's something to dig out there in the feature flag framework, if you're curious about that.
Yeah, intercept the query that's trying to do a Cartesian join on every order for the past 30 years. Don't do it.
But the reality is, like, solve this problem in Superset. It's still a problem inside the other tools, whether people use the CLI to query Presto. And people will be like, okay, well, Superset doesn't want to run my query. I'm going to, find a different way to attack and destroy the system, right? So sometimes like it feels as an operator of these tools like you have a barbaric horde of people that are trying to attack and destroy your software. I know like when I was operating Airflow at scale, sitting really close to the data infra team and in different organization, like sometimes we'd look at things, incident management, or like, you were trying to destroy our infrastructure here. There's no other reason. You wrote a script that, with nonstop, attack our system, like you're trying to destroy it, and then we dig a little bit deeper and then improve our immune system and come out stronger on the other side.
And in terms of the different data sources, Superset supports a large and growing number of query engines and data storage systems. And I'm wondering what you have found to be some of the most challenging, either specific systems or categories of systems to work with for something like Superset, where you're trying to enable interactive data exploration and visualization.
So I think on our front, the way that we integrate through different database engine, and it's a huge kind of integration point for Superset and other tooling, is how we connect to different analytics database engine, right? There's a bunch of other integration points, like for the metadata database, for the caching layers, and have multiple caching layers. But like going into the analytics database integration, so we do that through Python standard that's called DB API. It's a little bit shallow. It's not very prescriptive. It's a little bit loose. It defines things like connections and cursors, and it's pretty high level. And then on top of that, we use something called SQL Alchemy. That's a popular library, in the Python world. That's a SQL toolkit and an ORM built on top of that SQL toolkit. And we leverage the SQL toolkit quite a bit. And this knows how to speak different SQL dialects. So you can do something like write a query in a more object type of form, as in like select .group by, .filter, .this, .that. And then it knows how to generate SQL in different SQL dialects. And that's been challenging, the different SQL dialects. SQL Alchemy is a little bit shallow in terms of like what it defines and what it does not define. So it might know how to issue kind of a limit or row number limit on different engines, but it doesn't know how to truncate a date, for instance. So the semantics around using the function in different database engine are just not specified by SQL Alchemy. So we need to manage that in our own Python package, where we add more semantics around date truncation and around like how to handle the cursors and how to do things like if I want to get a percentage of completion of a query. So if you run a 2-hour long query on Hive or a 20-minute long query on Presto, it's great to be able to show the user that you're at, 39% and that, the query is still running. So we have a layer there. If you look at the Superset code base, it's under a package called DB Engine Spec for all the things that are specific to database engines. So it's like this kind of compatibility layer. And it's been a struggle to work with all this like vast array of drivers with different level of maturity. And we've written our own and we've contributed back to like the BigQuery, client and the SQL Alchemy dialect for it. So we've written the Elasticsearch one, the Druid one, a Google Sheets one that's a little bit more kind of fuzzy and complex, which probably brings me into the second part of the answer, which is one of the challenges has been that some databases don't speak very good SQL at all, or are learning SQL over time. So you look at our journey with Apache Druid, which didn't speak SQL at first and has been learning SQL and has pretty good SQL support now. So for instance, like some engines don't support subqueries. There's all sorts of things that they may or may not support, right? It could be window functions or it could be common table expressions, CTEs. So an example of what we do is sometimes you want to plot a certain number of time series, but if you group by customers, you might have like 10,000 customers, so you don't want to bring like 10,000 trend lines. So we'll run a subquery to say like, what are the top 10 customers based on this metric, and then do some sort of subquery join to do this. And for databases that don't support subqueries, by the way, it's great to have a technical audience because I can get into a little bit more details here. But so for the database engines that we cannot do a correlated join with a subquery, what we do is we do a two-phase query. So then the mechanics of Superset are like, I'm going to run a first query to retrieve a result. Based on this result, I'm going to assemble a second SQL Alchemy query that will be translated to the right dialect, and then get the top N time series with the time detail for those top N customers in that case, right? So fair amount of complexity there. And if you think about unit testing this stuff and guaranteeing, that you're not going to see too much regressions in this area as the drivers evolve, And as the dialects evolve, it's been challenging, but someone's got to do it. So we're definitely at the forefront of that. We've talked about refactoring this maybe as a contribution to SQL Alchemy or as its own package that would be a little bit more generic and that other people could use as a kind of this like slightly more involved abstraction to be able to talk to multiple engines.
Yeah, that was going to be one of my questions, is if this is available for the broader Python community to use in isolation from Superset. So you already addressed that question. And another interesting aspect of what you were saying with having to kind of remap some of these subquery joins or common table expressions for engines that don't support it, then you also get into some of the complications of transactional isolation and some of the different semantics about how databases manage that. And, are you seeing the same state of the data between those two query executions? And do they support transactions across multiple queries?
There's a lot, I wish we had a newer version of DB API that would be more prescriptive. There's all sorts of challenges too around exceptions that are returned from the different engines. They are not kind of inherited from the base class of exceptions too, or I don't think that DB API is prescriptive on that. I think it has some specification, but it's implemented in different ways, right? A lot of people go outside of the spec. So it shows the importance of a standard and of a spec, but the challenge there too is that if you have a spec that's too prescriptive, then people don't want to implement it too. So maybe from that perspective, DB API is a decent compromise. If any indication of that is how mature is the connectivity to database engine is in Python as opposed to other languages. I think Python is one of the language probably that does best in this area, not necessarily in terms of rigor, but in terms of things that generally work, right? So maybe right. On the Java JVM side, you might have more rigorous driver, but less implementations, a less diverse set of implementation.
In terms of the use of dashboarding tools within an organization, traditionally they've been used for just show me the data, I'll make my own decisions based on that. But as organizations grow in terms of their maturity of the use of the data stack, and the data stack itself continues to grow in terms of its capabilities and the sophistication of the people who are operating it, there have been growing trends in terms of how the dashboard is used. So rather than just being present the data to me, there's been more of a trend towards, rather than just business analytics, I want decision analytics. I want you to show me what is the data and then what am I supposed to do with it. So, maybe I see this trend line and then I just click a button. Okay, my stock is declining at a certain rate. I need to order more widgets right now, and then embed that right into the dashboard. And I'm curious what you have seen as the creator and user of Superset, how people are able to implement that style of analytics and that sort of evolution of the sophistication of how analytics are used to present to end users.
The big underlying trend, right, is democratization of access to data and then up-leveling data literacy in the organization. And where the model in the past was data, I think, was a specialty, right? Fundamentally, you would have maybe a small data team, or traditionally you might have a data warehouse architect that is in charge, or a group of data warehouse architects that are in charge of being the librarian of the data within the organization and structuring, organizing the data from different sources into a data warehouse. And then you would have the business intelligence engineers that would install things like business objects and MicroStrategy, and they would create abstraction layers in this, what we call back then the semantic layer. I know probably the audiences might not be familiar with that term, but it's an abstraction layer that enables people to self-serve a little bit more on top of the data warehouse. So traditionally, we'd see a lot of that, right? The tooling was oriented that way. And then you needed for the things to make it in the warehouse, in the semantic layer, so that then people could kind of self-serve. They could order things from the menu at the restaurant, to use an imperfect analogy. And I think we've seen people move towards much more of a buffet / open kitchen, where it's a big free-for-all and people are able to consume ingredients that are more or less processed, and there's a wider variety, and people are welcome to go in the back room a lot more, where maybe before the chefs was hey, I don't want any customers in the kitchen, right? They keep the customers out of the kitchen. Now we're oh, no, it's a big party. Everybody's invited. Anyone who has the skills can write SQL or write Airflow jobs or create a dashboard. So if I take that trend and kind of translate that into like what we see in terms of like Superset usage pattern or dashboard usage pattern is before we would have like specialists creating dashboards for executives. It might take the specialist team like months to create a dashboard that would have a life cycle of many years, right? Like the CEO dashboard that's been built by a group of specialists, and this dashboard will be pretty much, more or less the same over the next few years. So the trend that we're seeing is an acceleration of how many dashboards are created, and we see a shorter life cycle of dashboards. So if your team is working on a particular product feature or set of feature, or an analyst team is focusing, say, on a topic like the effect of COVID on, listings at Airbnb or something like that, right? Like they're probably going to build a dashboard for that, accumulate a set of learning. And as they tackle that area and build the knowledge and an understanding and make data-informed decision to change the product, this dashboard will probably get, just unused over time. And then they'll go to work on whatever the next hot topic is for that team or that smaller group of people, and then probably create a new dashboard. So definitely a trend of like more people building things that are more short-lived and aligned with more operational use cases too. And by that, I mean the dashboard that supports the daily work or the weekly work of a particular person or team. And that's when I think more value is typically delivered at that point, right? Because you have something that's more targeted, that supports the process more accurately or more deeply. It's just more fitted for a smaller group of people. So that's clearly a big trend in analytics.
RudderStack's smart customer data pipeline is warehouse first. It builds your customer data warehouse and your identity graph on your data warehouse with support for Snowflake, Google BigQuery, Amazon Redshift, and more. Their SDKs and plugins make event streaming easy, and their integrations with cloud applications like Salesforce and Zendesk help you go beyond event streaming. With RudderStack, you can use all of your customer data to answer more difficult questions and send those insights to your whole customer data stack. Sign up for free at dataengineeringpodcast.com/rudder today. The other big trend that I've been seeing in analytics and dashboarding is starting to integrate some of the data quality indicators into the dashboard so that you can see as a consumer of the dashboard or as somebody who's doing some exploration, this is the last time that the data source was refreshed. This is some of the lineage information. These are the data quality checks that were executed. You can see that they were all passed, or, maybe one of them failed, but it's not critical. So you can understand as you're doing these explorations or as you're viewing the dashboard, how many grains of salt you want to take with it.
That's, one underlying trend with that. So there's a clear need for that context, right? So while I was at all three previous companies, I was sitting really close to the teams that were working on, call it metadata discovery or metadata management, data dictionary, but that's just a huge area. So at Lyft, I was sitting right next to the team working on Amundsen, which is an open source project in this space of like data catalog and metadata discovery. While I was at Airbnb, I was sitting really close to the data portal team that have published. So data portal is not open source, but they have published a lot of their experience and a lot of like very interesting and influential information around data portal. So I encourage people to go and dig and Google data portal Airbnb. They're going to find some interesting information in the space. And similarly, my team at Facebook owns something called iData, and we're really close to the team working on metadata graph. That was really a metadata graph. So been really close to that space and multiple environment. I think it's validated that we really need more of this type of tooling and context. Some pointers in this is like there are some emerging standards in the space. I'm really excited that we see a few standards I want to mention. So one is Open Lineage. That's an open source project that's really interesting. That's, I believe, was started by Julien Ledem, who is the original creator of Parquet. And I believe like very involved into Arrow, and there's just a prolific, amazing person. And I think around this project, we start to see a consensus from the different kind of actors in the space, right? Like, so for us, we raised our hand and be like, hey, if there's a standard, we want to be part of it. We want to implement it from the Superset project standpoint. I think the Airflow and Dagster, I think, and then projects like Data Hub and Amundsen are definitely also raising their hand to say like, if there is an emerging standard, we absolutely want to be at the forefront of implementing it. Another pointer is something called Marquez, I believe, which is kind of if open lineage is the standard and the spec, Marquez is kind of reference implementation for it. And it's a pretty sweet project that I would encourage all data engineers to check out, especially as it takes shape. What does that mean for Superset? Well, first thing is, as these standards emerge, we want to implement them. And even in the absence of standards, we want to integrate like with the actors in the space, really, right? Amundsen and Data Hub and whoever else. So we're at the forefront of like wanting to implement that. We have some hooks already. So one thing more on the data quality side is, in Superset, we have the ability to semantically certify data sets and or metrics within these data sets. So you can do that through a REST API, or you can do that in the UI, which adds a little metal or a little like stamp by the data set that says this has been certified this person in this context, so that people navigating the tool can get a sense for which sets of objects they can kind of proceed with confidence with, and maybe which set of objects maybe they need to be a little bit careful. This is not a certified data set. So take that, and I think it's more like a positive in general, just to say this is a certified data set, so you can play with it, and that the metrics and dimensions that are going to come out of that should be trusted. So, really looking forward to the emerging standard, implementing them, and providing a lot more context within Superset, so that when you're in a SQL IDE, you should be able to get the lineage context, and you should be able to navigate to something like a Munson and get even more context, so you can really understand everything you're doing. Who's the owner? When is this data set, typically landing every day? Who else is using this data set? Where's the logic for that? So if I need that for reference, I can get access to it very easily. So I think that will be a trend in the tooling, where we're going to see the tools talk to one another and exchange metadata in a much better way than they do right now.
Yeah, definitely excited for a lot of the developments there, and open lineage in particular. And another interesting element of the kind of data quality and data lineage aspects, and the dashboard being, probably the first place that people are going to be interacting with the data, is how it factors into the overall governance strategy. How does Superset act as a facilitator of the data governance strategy?
I remember the term data governance is kind of overloaded too. So we should try to define this. So I remember back in the days, we had data stewardship and data governance as two different things. I know, data stewardship too and governance, that's some aspect of data access policy, of like having people who can define who can access what. And then I guess there's another aspect that's just like the certification and validation. What are all these data objects, and who owns them, and are they reliable or not? When you ask about data governance, curious about what you think exactly.
Yeah, data governance definitely has become overloaded, and I kind of tend to use it in the broadest form because that's kind of its original intent. It's been narrowed in scope in a few contexts to just mean, access control and privacy management and regulatory compliance. But I think you kind of answered broadly that Superset is useful in this context because it does have access to some of the lineage information and the data quality checks, and because the security layer is extensible, you can enforce some of the access control and privacy management to do things like data masking before it gets shown in the UI, things like that.
Yeah, so Superset definitely enables people to have very complex data access policy. If they are able to express it, on a piece of paper, they should be able to implement it and enforce it inside Superset. I think a lot of the challenges in this space are, they're organizational. In any given organization, if you ask who should have access to what data, it sounds easy at first, but it often reveals itself as an infinitely complex question that no one really owns, and ends up with kind of half-assed solution. Pretty often people are like, okay, well, we explored this. It's extremely complex. Let's go back and say there's going to be 3 level of access here. So Superset definitely enables a lot of this. There's inherent challenge around constraints and guarantees there too. So if you have a lot of process and requirements and constraints around governance, that fundamentally kind of plays against some of the data democratization, aspects of things. So there's different forces at play. Like one is like, the more chaos of like, enabling a lot of people to do what they want. And then there's like making sure that, they don't shoot themselves in the foot and that, we get to cohesive answers. And I would say history right now is going the direction of enabling more people to do more things, a little bit more chaos. I think we've seen that maybe it's like 2010 to 15, 16 as a general trend. And then, with GDPR, I think that was like 2017. I think there's a little bit of a counter force there too of like, hey, we need to know who's accessing what, and we need to be able to audit this and control certain things too. So multiple forces at play. I think organizations should be able to define their policies and enforce them in tooling like Superset too. So we don't necessarily to be too opinionated on that too. And we want to enable people to just define their policy and implement them in our tooling.
For anybody who wants to learn more about Superset and follow along with you and the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, what do you see as the biggest gap in the tooling or technology for data management today?
I think like the metadata integration we talked about, so having a better metadata exchange that can really kind of weave in the different tool sets together and preserve context. So that means like it should be easy to navigate from things like Amundsen, Airflow, Superset, and to consume all of that business metadata, operational metadata, lineage metadata in a way that it feels like a set of tools that works very well together.
Well, thank you very much for taking the time today to join me and share the work that you've been doing at Superset and some of the ways that it can be used in data organizations to help satisfy their needs. It's definitely a very interesting tool and one that I plan to take advantage of myself for my own work. So I appreciate all the time and effort you've put into that, and I hope you enjoy the rest of your day.
Excellent. Thank you so much. It was a pleasure to be on the show again.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.